All right, mean value theorem. So first thing you need to know is there's two things that define it. First thing is your function f has to be continuous over an interval, closed interval, a and b. So it can't be anything that looks like that. That's clearly not continuous. Like, look at that. Like what are those? What are those? No, not continuous. And then the next thing is it has to be differentiable over an interval, an open interval a, b. So they give you a little bit more leeway there. And so your graph can't look like this. So clearly not differentiable here, here, or there. What that means is you can't find a derivative right there. So if this was like a and b, like it's not differentiable over a and b in this case, like this. And then there's a formula that goes with this, something that looks very, 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 very familiar. It looks like something like, was it like f of b minus f of a over b minus a. Well, all this is slope. It's just a gradient or slope, the slope formula. And what they're saying is the slope between 2 points on the curve is going to be equal to the derivative at some point c on the curve. And I'll show you what that means. All right, so here, let's say, I'll just put a graph here, just so, you know, anyway, I don't care, whatever. So, derivative, if this is f of x, derivative represents the instantaneous slope somewhere on this curve. So for example, if I choose a point here, the derivative would be the slope of a tangent line on that point there. So then we'd say, let's say if this was, I don't know, c, the slope of that line would be the derivative of f of x at that point c, like that. So that's what the derivative represents. It represents the slope anywhere on this curve. So for example, let's choose here. Let's say that's, I don't know, g. So then the slope of this tangent line here would be like this. And we'd say, okay, the slope of that tangent line is represented by the derivative of the function at g. And I'll go over that in a second later too. So just remember, derivatives, you're talking about the slope of a line that's tangent to the curve. So look at this here. Here is my curve. I'll say this is f of x. All right. And since we want to work with the mean value theorem of MVT, we'll say, you know, this formula again, f of b minus f of a over b minus a. And I swear to God, if you don't remember this, like it's just this, y2 minus y1 over x2 minus x1. If you graduated high school without this, so anyway, okay, anyways. So let's say I'm going to use my interval a and b. I'll just say anything. It doesn't matter. A, b, A, B. So here's a. And here's b. Doesn't matter. Okay. So what this is calculating is slope, but another name for slope is average rate of change. So if I put my point, you know, this a here, and then b goes right here. So these are my two x values, x1, it's x2, you know, very, very simple, or other way around, doesn't matter. Then I need a coordinate. So the coordinate here would be obviously a, that's the x value. But then my y value here, it's just f of a. What that means is the function at a. So it's like if I plug in a in the function, I'm going to get my y value. That's why they say f of x, your function at x, like that. And then so for b, of course, b is x, the x value. The y value is just the function at b. So this is f of b. That's where this good stuff, that's where this junk comes from, all right? So now what they're saying is, okay, if you find the average rate of change of this line here, you find the slope of that line, which is the average rate of change, it's going to be equal to the slope of some tangent on the curve between a and b. So somewhere between here on the curve, so I'll just box it up. So somewhere here on this curve, in that box, you're going to find a point where its instantaneous slope, or the slope of the tangent line, is the same exact slope as the slope we got here for a and b. And a good picture representation would be, you know, if I put a point somewhere probably like right here, I'm just guessing, something like right here, that would have a similar slope, or actually the same slope. I'm just estimating, so right there. So clearly it's not going to be like here, it's not here, or like not here, that's not it. It's going to be down here somewhere. That's just a guess. So you can see these are the same slope going the same direction. Tee. All right. So look, okay. Let me give you an example function. Let's do f of x equals, oh, I don't know, 3x squared. Let's try to do something easy because I'm not good at math. Minus 4. Okay. So we're messing with this right here. F of b minus f of a over b minus a. We need a b and a. I don't know, let's say, these are elements of x, is what I'm saying. So my interval is going to be between, I'll say 2 and 4. So those are my x values. So I need my y values. To get my y values, remember, the function of x. So I plug in my x values. Watch me plug it in. So, okay, so then f of 2 equals 2 squared minus 4. Remember, looking for y values. This gives me my y value. This gives me my y values. So, okay. Oh, so complicated. 2 squared, is that like 4 or something like that? 4 times 3, I think it's 12 or something like that. I don't know math, don't tell me about it. So this is going to be 8. That's my y value. I think I did that right. I did it right. Okay. So 4 is going to be 3, and then 4 goes here, and then that's squared, and then that's minus 4. And then, oh, of course it's a big number. 4 squared is 16 times 3. 48 minus 4. 44. All right, I think I did that right. If I didn't do it right, then you can sue me. Okay. All right. Now, my 2 points are 2, that's my x value, and when x is 2, y is 8. So that's what we figured out. And then this one, when x is 4, y is 44. All I did is plug this into the original equation. So those are my 2 points. So now I can take this and do this here. I'm doing the slope formula. Remember that? Remember high school? Okay. So let's just do 44 minus 8 over 4 minus 2. 4 minus 8 was, I think, 36 or something. So big. Okay, minus 2. Oh my God, I did that in my head. I'm gonna take this to my parents so they can be proud of me. Okay. So the slope between these 2 points here, or the average rate of change between those 2 points on this curve here, is equal to 18. So I'll say the slope, average rate of change, is equal to 18. So the mean value theorem says, okay, if that's true, then there's some value on this curve at the derivative that's going to also equal 18, some value. We're going to figure that out. First, we need the derivative of f of x. So we want this. So if our function is 3x squared minus 4, oh, that's easy. That's just going to be 6x. I did the power rule. So now the mean value theorem says, okay, there is some value for x where we're going to get 18 for the slope, which means if I put in something for x, I'm going to get 18. You're saying, okay, there's some place on this curve with instantaneous slope is 18, so you got to solve for x. So here, x is equal to 3. So because of the mean value theorem, it says, okay, when x equals 3 on the curve, if I plot a point right there, x equals 3, the instantaneous slope is the same as this, what we found here with these 2 points, like that. That's all. Go to sleep. Go to bed.